Hello and welcome to our first Decision Fest panel of the day. Our topic is the path to production, exploring the software interface with operations research. My name is Haley. I'm part of the Next Move team supporting today's event, which features a conversation among these panelists, Ryan O'Neill from Next Move, Chris Pryer from NFI Industries, and Ryan Marcus from Carvana. With the two Ryans today, we will have Ryan O and Ryan M. We will do our best to remember this. I'm going to let them introduce themselves here in more detail in just a moment. But first, I'd like to give a few notes for today's session. So today's session is meant to incorporate your questions and comments, which you can share in the chat off to the side. Just be mindful of that host and panelists versus everyone toggle to make sure that your message goes to the right audience. There's also a Q&A feature at the bottom of your screen that you're welcome to use. A few of us from Next Move will be monitoring the chatter today, and we're happy to help surface questions for the panel throughout today's conversation or during some dedicated Q&A time at the end. Our time today is somewhat flexible. We're likely going to end around the half-hour mark, but we have a little wiggle room at the end because we have a session happening right after this, which is very exciting. So if you aren't able to stay for the whole session, don't worry. We are recording today's session and we'll make sure to share it with you afterwards. And with that, I'm going to hand it over to our panel to dive right in. I'm looking forward to the conversation today. So Ryan O, feel free to take it away.
Thanks, Haley. And thank you, Chris and Ryan, for joining me today for Decision Fest. And thank you to everyone who's tuning in. So let's kick it off with some intros. I'm Ryan O'Neill. I will be your moderator today. I'm not normally a last name guy, but given that we're in this sort of unusual circumstance of having two Ryans, I think we'll make an exception. A little bit about me, I've been in industry about 25 years. A good chunk of that first was just doing software without any understanding of what optimization or operations research were. Then back around 2006 or so, I was working on political micro-targeting software and infrastructure for Get Out the Vote campaigns and started to become interested in quantitative models and AI. It was AI that led me to operations research through David Goldberg's wonderful book on genetic algorithms. And I've sort of been in love with it ever since. So I did all my graduate work part-time at George Mason University under Carla Hoffman. Cut my teeth on OR at MITRE, and then got into the routing space from there. So I've been in routing for a while now, and I met Carolyn Mooney, my co-founder of Next Move, at Zoomer and Grubhub. And one of the things I think that's really interesting about like real-time routing is it really moves the modeling context and the optimization context from something that's a little bit more analyst driven to something that's like real-time operational. And it suddenly becomes even more interesting. So I'm hoping we'll get into that a bit today. Ryan Marcus, why don't you go next?
Yeah, thanks, Ryan. Thanks for having me. So my name is Ryan Marcus. I'm a decision scientist at Carvana. I went to Northwestern University. I studied industrial engineering and transportation and logistics. And then I worked for JB Hunt for about 5 or 6 years coming out of school. And then I've been with Carvana the last 4.5 years. And most of that time has been in optimization and operations research, a little bit of predictive modeling and machine learning, but my focus has just kind of organically been on near real-time optimization models. And so through that, I kind of learned a lot of software engineering principles and kind of combined that with the operations research perspective.
How about you, Chris?
Yeah, so first of all, thank you for inviting me. I'm super excited to be here, and I think this is going to be an awesome conversation. So my name is Chris. I work at NFI Industries as a principal software engineer, and you can think of NFI as a supply chain company. I work under the transportation management department, and the transportation management department specifically, you can think of as like an extension of your supply chain. So I started my career at NFI as an intern, actually, and when I started, some of my first experience, actually, Ryan O, you kind of mentioned this, and it resonates with me, which is a lot of the optimization capability that I saw joining NFI was very analyst driven. So, early on, some of my experience was around helping out with these robust supply chain studies that we did for our customers. And that might be something like looking at the layout of where our customers' supply chain facilities are across the country, or how it's structured. It could be vehicle routing, it could be driver scheduling, all these different kinds of optimization uh, use cases. Nowadays, I work on something called the digital twin, which you can think of as a decision support system. And a lot of what we do is it revolves around the routing space at NFI. So you can think of it as a system used to run different routing scenarios. For example, we might have transportation operators that are looking to understand what happens when they relax certain constraints around their model. But yeah, looking forward to the conversation.
All right, so now we've got some intros done. Ryan Marcus, you're an operations researcher, decision scientist by training. Chris, you're a software engineer by training. We're talking today sort of about the melding of these things, right, into decision support that's integrated into software stacks. I'm not actually sure off the top of my head if I'm not going to use the word term dark side because I'm not sure which one of those is the dark side. But can you talk a bit more about your original training and early experiences with the other side, so to speak? And Ryan, let's start with you.
Sure, yeah. So, yeah, like I mentioned, I studied industrial engineering, so definitely had some classes in operations research at school. I took one computer programming class in school. It was a C++ class. I did not like it. So that was interesting. And I came to JB Hunt and I was asking about their vehicle routing algorithms. And I think that combined with technical interviews got me placed on kind of more of the coding optimization team. So on the software side, I learned it almost 100% on the job, and that's where I learned that actually, no, I do really like it. I do find it very interesting. I just needed some practical real life applications to kind of bring out that enthusiasm. So yeah, I got put on kind of a project where we were doing kind of real time assignments of resources to tasks, and it was a lot of debugging. We'd get a lot of questions on why is it assigning, this, or why is it not assigning this, and so just kind of doing a lot of that debugging and figuring out are there bugs or there parameters that need to be changed and where does the data come from and what other systems is this optimization interacting with? So learned a lot on the job from that.
And Chris, did you sort of gain all your sort of digital twin optimization stuff? Was that mostly like learned on the job, or how
Yeah,
did you come
yeah.
into that?
Yeah, when I started as an intern actually, I want to say in 2016. And the team that I was joining was this brand new supply chain design team. So we were immediately thrown into the thick of it, just sort of right out of the gate, studying our customer supply chains and immediately trying to find optimizations that we can make and improvements we can make to their supply chains. But I think what stood out to me, because in college I was, deep into the software world. I had been going from hackathon to hackathon and project to project and studying with a bunch of my colleagues in college. We were a big part of the ACM organization. And I remember going into this supply chain role or this decision science world and seeing some of the network studies that we would do and thinking, oh, wow, these are the kind of systems in and of themselves. And from there, I was pretty much attached. I kind of, went from one problem to another and kind of fell in love with the domain.
Cool. Yeah. Falling in love is a good term for it. Yeah, that definitely happened to me. I remember uh, during my first class on deterministic models, I walked into the class and I walked out and being like, okay, this is what I'm going to do. This is it. Um,
Yeah, and Ryan, I had that same exact experience because I did civil engineering for 2 years,
oh yeah.
and then I switched to industrial, and I had that deterministic optimization class. I knew right away, yep, this is
Yep.
this is where I should be. So,
It's probably good it wasn't stochastic because I would just been a little terrified and confused. Ryan Marcus, one of the things that you mentioned that really grabbed at me was like debugging assignments and trying to explain sort of counterfactuals to people, like why did it do this? Could you
right.
dive a little bit more into that? We did a lot of that at like Zoomer and Grubhub, and we'd work with the ops people a lot, and it was very challenging. So I'm curious what your experiences were with that.
Yeah, absolutely. And on that optimization program I mentioned, I would classify it as an opt-in system where we were providing recommendations, but the planners had to go to a specific page to view the recommendations and then click a button to accept them, versus like a system where it's just
Yeah.
default system plans and they would have to override it. So a lot of that job was selling the optimization to the planners because they didn't have to use it. They might have some pressure to use it more, and we were doing a lot of collecting of stats of who's using it and how much. Um, it was it was a combination of the sales role with the engineering, with the operations research, and I would actually travel to different locations because a lot of them were on site, not at corporate. And so it was a lot of time sitting with the planners, seeing how they thought, seeing how they made trade-offs in their mind, and kind of thinking, what if this, what if that? And a lot of things that they would plan would be a local optimal if they were just looking at one resource and one task, whereas the optimization is doing a little more of a global optimum. But that was definitely a challenge because that requires a lot of trust from the planner to know, like, I could make this one assignment better, but I'm trusting the system that it's going to make other things better if I do it one way instead of another.
Yeah, and it's that sitting with the ops person that really is like that's sort of the key to the job, right? And that's why how we're not going to be replaced by AIs, I think, right?
Right. And I was
Yeah,
forced into it on that one. And I'm glad I was because I learned that I
yeah.
enjoyed it and I learned how important it was. And if I had kind of been thrown into a different role, like I might not have had those experiences. So,
And Chris, I believe you've done very similar things working with some of
Yeah,
the users early on.
exactly. I'm actually, I love that you brought this up, Ryan. And so uh, I was actually curious because that is a big part of what we've done. A big part of this is establishing that confidence and that trust. And these things can be complicated. So I was curious, like, how did you manage that? From I guess project to project. Like, did you interact with multiple teams and have different styles or approaches to manage that confidence?
yes, yeah, definitely different teams for different projects. A lot of it is, I think, psychological of you kind of just sit with someone and there's the math and the software and the assignments, and then there's also the person in front of you and who they are. So part of it is just building that relationship and letting them know that just a person just like they are. I'm not just some person sitting on a computer screen coding things and forcing them to try to do what the system wants them to do. And kind of building that trust, asking them a lot of questions so they know that I'm curious, I'm interested. And I would also kind of tell them, like, the system we're building is your system. Like, when you find things that we're doing incorrectly, we can put your logic into the code. And now it's like a living, breathing thing that you helped build. So I think that was helpful as well.
Yeah,
But yeah,
there's
just
this.
being very responsive to emails and communications as well.
Yeah, I'd say this is almost like how you deploy the model itself with the operations people. Um, there's also this aspect that, and we're talking a lot about software today of how we get these models into production environments. Um, Chris, you mentioned that early on you were working doing sort of a lot of like analyst style work, one-off kind of studies, and now you've been working on like digital twin simulation.
Yeah.
Um, how do you put these things into production environments? What components do they have that are the same? How do they differ?
Yeah, I guess the first thing that comes to mind is actually use an example of where it didn't work out, where we had a lot of challenge or struggles actually embedding that in a process that existed. So we like kind of like what you mentioned, a lot of it is somewhat analyst workflow, if you will. That's kind of how I have looked at it. And I look at that as like these are, capabilities that other people want to be able to tap into. And we had a very specific team who wanted to leverage a driver scheduling program that we were working on as part of a larger study for a customer of ours. And we were trying to figure out how to ship that for that team and make it available for them. And the immediate thing that comes to mind is, especially with this sort of stuff, would be a robust DevOps capability, right? I mean, having the ability to not only spin up the resources available and make them available compatible with, from my perspective, we have a lot of um, procedures and logic in place around data security, for example, right? So, it's not just about enumerating the different resources that you need in order to make this a live business process, but it's also about understanding like what resources do you have available to you and how you plan to use them and make them compatible with other systems and processes.
Yeah. Yeah. Um, what sort of challenges are there sort of, so you're talking about resources, like what makes it hard tying optimization into software?
Yeah, I guess one, there isn't a clear interface, right? So like if we're talking about, for example, like a vehicle routing
Yeah.
solver, right? You don't have an API that is exposing that to other systems and making it available. You don't have underlying resources making that, scalable infrastructure as well. So it's, I guess this is one of those things where like, how much time do you have? It's sort of like
Yeah.
we can talk about a number of different areas, related to that.
Yeah, I'm curious, and maybe Brian Marcus, I'll ask you this: have you ever been in the situation where an optimization model was under resourced for the task that it needed to do, and it wasn't able to accomplish it?
Yes,
Yeah,
and it can be under-resourced from it's too big of a problem for an optimization solver to solve, and you have to shift to heuristics. There's also just the amount of data when you're provisioning and deploying, and maybe it's consuming more memory or more CPU than you allocated. Usually that's kind of just like a quick fix of increase the resources, but then you might bump up against limits that are set in place, and you might have to really go back in the code and try to make things more efficient. And then, yeah, in terms of like what Chris was saying earlier, of like building UIs and building APIs that expose and visualize things, and how much time do you have? That's always a big thing where, a lot of times you start with a model that's outputting to a spreadsheet because that's kind of what existed before, but then you really need to build out something that's kind of more robust and more scalable, and people like using things that are visual, and so that's kind of a
yeah,
big component of how do you build something that they can see and play around with. So
Yeah, and
yeah,
even from just like if you think about the driver scheduling problem, it's like what we were building was for a dedicated fleet team. And that team has maybe like 10 or 15 engineers on it that would use that. But the underlying component there, if we were to make that available for more people, they could have different problem structures themselves, right? Which has an impact on how you want to use the underlying resources too. And it's sort of like, to me, being able to, as you mentioned, provision machines flexible for those resource requirements is super important for this kind of stuff. Like if you're making this available for teams with, let's say, many shifts, right? That they're trying to assign versus another team that there's really just a select few number of shifts, that problem looks different, and being flexible and handling that use case is important, I think, in this space.
yeah. One of the interesting conversations I've had with people when we were with like SRE types or software architecture types, when we were onboarding optimization technology into a platform, was about scaling, and how just sort of the unpredictable nature of optimization. And when you talk to the software people, they'd want to know, like, okay, well, how many number of inputs does it scale up to? Like, what's the n, right? And
Yeah.
it's like, well, I can't really tell you that because I can give it very small problems that in certain circumstances the optimization won't be able to solve in the time that you want, and I can give it very large problems that it will. It's like it's just not this sort of clean sort of predict response curve.
Yeah.
Um,
I feel
and,
like
and
it,
and it can't really necessarily be like divided up either horizontally.
yeah, I feel like it's just like a very observation-driven workflow,
Yeah,
right? And that's
I like
experiment.
that.
It requires iteration, which I guess, these are things I'm saying it out loud, and it's like it's very software principle like, right? But like you're mentioning, it is, I think, unique to this industry or to this area or specialty. It's like, to me, at least, having a robust capability to be able to iterate and observe changes and test and experiment, I think makes these projects more, uh, scalable in nature and how you build it.
Yeah. So let's talk a little bit about other stakeholders of these optimization software systems. So at Next Move, we think of this optimization infrastructure in terms of what we call decision ops. That's basically the glue for getting models live and keeping them live, keeping them happy and healthy. How do you all describe decision ops as a concept and practice to stakeholders and peers in your organizations and network? Ryan, let's start with you.
Yeah, so I have two answers, I guess, depending on who the person is. If they are in data science and machine learning, the kind of simple, easy cop-out answer is it's ML ops, but for optimization. And similarly for a software engineer, it's DevOps for optimization.
Yeah.
Yeah, the added, I guess, complexity is, like one example is A/B testing in the software world. You could just say, do one treatment for this customer, one treatment for that customer, do that a bunch of times and do statistical significance. But in our world, what we do for
Yep.
one customer affects the other customer. And so there's a lot more, it's not as isolated and independent. And then that leads to more sophisticated methods that you need to use in decision ops. And then for someone that might be non-technical or a business stakeholder, I would go with the metaphor of we're building you a house or let's say a palace. And decision ops is kind of the plumbing, the electrical wires, everything under the hood that you don't see that keeps it, in perfect shape, that alerts you when things are off a little bit, that allows you to test that improvements are going to perform well before or during your production rollout. And so it's all that kind of under the hood stuff that takes time, takes thought, takes strategy, but that we wouldn't be directly exposed to in the business.
Yeah. Yeah, Chris, I know you've had a lot of conversations at NFI about this sort of thing. How do you talk about decision ops there?
Yeah, I mean, Ryan, that was a great way to put it too. I think, even coming to this panel, I was thinking about the same exact way to put it, ML apps for optimization. And it's really just like the specialization that is optimization and how that applies to DevOps. And I think just relative, uh, like those similar verticals. I, to be honest, I don't know how to add to that. I think that was a great way to put it.
Yeah, I think one of the interesting things about optimization in particular is, that there are so many sort of problems that you can solve with it. If you're looking at things from the machine learning lens, it's like there's a lot of techniques, but the number of actual problems that are the output of those techniques are usually regression, classification, or a few other things, right? There's a small number of final applications, right? Not like there's like LLMs and things like that. So you're applying those models in different ways, but the models themselves, like the basic structure of them, um, uh, is somewhat uniform, right? There's just not that many categories. But when you go into optimization modeling, it's sort of like the sky is the limit, right? And so like it just adds so much more complexity to the operational aspect of this.
Yeah.
So let's talk a little bit about career before we wrap up. If you all could go back in time to your earlier career selves and just give a couple pieces of advice related to the software engineering side and deploying models, what do you think those things would be? Chris, let's start with you.
Yeah, so man, so if I look at intern me, and I think what kind of advice can I give myself? The first thing that comes to mind is time to value, I think is a really important metric, I guess. I don't want to be super formal with it, but
Yeah.
to use as a rubric or like guidelines. Like the think of like some of the studies that we did, let's say if it was a vehicle routing study. And what we're effectively doing there is we're looking for enhancements or improvements or inefficiencies with existing plans and trying to improve them and explain what those improvements are. Understanding what that value is and what that means to, for example, a customer or to an internal operator, understanding what that value is and being able to bring that value as quickly as possible to those end users, call it, I think is really valuable. I think, or really powerful. It's being able to turn around value quickly is an incredibly valuable skill. Another piece of advice I'd probably give is don't be afraid to or embrace failure in a way. I don't want to say like just go and fail at everything, but uh, what I would say is, you're going to fail at times. You're going to try something, it's not going to work out. And it's really important to embrace that as, a learning opportunity and a process for improving. So, people like to call it fail fast. That's kind of how I like to think of it. And then I think finally, maybe like a third one that I'd give myself if I looked at, intern Chris, um, is don't be afraid to push for the things that uh, through observation, through testing, work really well, right? When you find something that sticks, when you find something that works really well, uh, drive it to its end conclusion. That's probably what I'd go with.
Yeah, the failing fast really speaks to me. When I think about like models that I've built and things, most of the things that I've tried have not worked,
Yeah.
right? And it's just you have to sort of develop this tenacity and sort of thick skin to that, and willing to just to walk away from something that you think is beautiful and will work beautifully and it doesn't. Um, the other thing that you mentioned so I worked with Carla Hoffman as my advisor, and she would always tell us, when you're taking on a new project, the first thing that you want to do is implement the simplest model that
Mm.
can give them the output that they're expecting to show that you understand the problem.
Yep.
And just do that as quickly as possible to get essentially stakeholder buy-in, and then go from there. Don't go off and build like some crazy thing that accounts for everything and it's going to take you 6 months.
Yep.
Ryan Marcus, let's move over to you.
Yeah, and I totally agree. I want to build on those points because those are kind of, it seems like Chris has learned a lot of great things since his internship back in the day. But yeah, on the time to value, I think that's one of the things that might separate academia from industry is it's often go with the simplest thing that works that you can build quickly. And a lot of times I've found that means there's a lot of things on the software side to fix before you really go
Yeah.
deep on the optimization algorithms. And so that's kind of like I've gravitated in that direction sometimes because I just identified a lot of quick things to do on that side to make things better. And then yeah, on the point of failing and failing fast, I mean, you learn the most through failure. So and especially in the optimization world stakeholders and planners, it's much more difficult or much easier for them to tell you what is wrong than what is right. So often getting something in front of them where it's tangibly wrong leads to better feedback than more abstract, theoretical, like how should something be done. So it's actually failure can be a good thing. And part of that is just communicating. This is a prototype. We're going to build and iterate. You're going to help us identify what's wrong and then iterating quickly to show that you're making it better and better builds that trust. And then yeah, the one thing I would add in terms of earlier in my career is I wish I had put more focus on testing and building and writing tests that last. So when I would make changes, I would test it, but it was more of kind of just like a manual testing of running the code, verifying what I expected it to do is what it did, but I didn't leave behind a lot of regression and unit testing so that when the next person came along, those tests would be a safeguard to make sure that things didn't break in the future. And so that was just something kind of I learned later in my career, and then all sorts of other, integration and end-to-end testing, but that all kind of really makes for a more robust system.
I think we'll have to have you all back for a talk about that at some point because that's an important topic to us
Yeah.
too. All right, so I think we're getting to time. So Haley, I think do we have questions?
We do. So there's some good chatter in the chat off to the side. And we did get one question coming in from Carolyn. So if you rewind back into the conversation here around operator buy-in, end user buy-in, she asked, do you think the different structures for using decision models, so for example, opt-in versus opt-out or human in the loop, make the architectures that you're working with or responsible for more challenging? There's some
Interesting
nodding and there's
question.
some
Do
thinking.
they,
Yeah,
do
you
they make
spoke
the
first, Ryan M.
architectures more common? That's a, yeah, I'm not sure. I mean, I don't think they've influenced the architectures too much. I'm thinking just kind of at the end of the day, what the system is outputting is going to be kind of the same. It's just sort of whether it is set in stone or kind of put in this isolated place where another step has to be made to move that data from a recommendation to an actual executable decision. But I do think in terms of getting the stakeholder buy-in and improving things in the long term, you want to get to the point where the optimization is making more decisions once you have that level of trust. Because that's just, it's more scalable. You don't have to build more and more teams out to make those decisions if the system's doing more of the heavy lifting.
Sure.
Yeah, so Haley, you kind of cut out for me. I think I'm reading that was Carolyn's question
Mhm.
on do you think different structures for using decision models uh, opt-in versus human in the loop? I could see where Carolyn is going with this. Um, I think it just depends on how you expect, for example, if we start with the human in the loop side of it, how do you expect for them to interact with it, interact with the system, interact with what you're building? I could see there being some changes or differences in how you'd want to design that, but I can also see how, a lot of what you would build could be abstracted to be reused by whatever interfacing that human in the loop is doing. So I think it's a, it depends kind of question.
Yeah, I
Good way
think
to.
there were I've been at a couple of instances or cases where we had operational systems that were built for entirely manual operators. And then we tried to convert them over to automation, right, and optimization. And those were challenging for a number of reasons, but one was just that the workflow was built for them to do things. It encouraged them to, take action. And when you now want to move them into an interrupt workflow, you need a different user interface for that, right? And it's kind of like what you were saying, Ryan, with you have these systems that are built for where it makes recommendations and they sort of accept them or not. Um, it was difficult for us to move them from a user interface where they were intended to take all of the actions themselves into one where the automation was taking the actions and they were supposed to just override things that were wrong.
Mhm.
Yeah, I think what's
Yeah.
kind of interesting from my side, I guess where I'm thinking about right now is what we're doing more recently. I don't know how far I can talk through the details, but you can think of it as like a lot of the value and the enhancements you can make around planning. If that planning is being done with a human in the loop process, which most, I think, when it comes to planning large scale product shipping, uh, you're gonna want a human in the loop, and they're gonna
Yep.
have systems that they interact with. And the way that we look at that is how can we kind of proliferate those insights, proliferate those improvements or changes in a way where it kind of fits their current experience. Like it's sort of like how can we embed those insights and that data, that information in their existing workflows. So yeah, I think this is one that's
Yeah.
like actually personally really interesting to me.
We'll have to have part two, maybe a part three uh, conversation on top of this one. But for now, I'm actually going to wrap us up for today with a few closing items just for people to be aware of. There's a couple of things happening in the month of December and then things to prepare for in the new year. For those of you that are following along or not following along just yet, the Advent of OR, which is being hosted by Feasible, is happening from now through December 24th. And you can follow it on LinkedIn. We can share that link with everybody here after the session. There's more Decision Fest this week, and actually in the next half an hour here. So we have another session today, and then a couple more this week. So feel free to check those out. And then Friday, December 19th, there's actually two community events. One that's a bit more European hour focused through Optimization for All. And then one that's a little bit more North America, South America hour focused with the Analytics Virtual Happy Hour. So those can be checked out as well. And then in-person conferences to just be aware of a couple months out. Informs Analytics Plus is happening in April, as is the Euro Practitioners Forum annual conference, also happening in April. So we'll make sure to share those links with everybody after today's session. So I think Ryan, and Chris, big thank you for today's conversation. Very much appreciate it. We look forward to next time. Thank you, everyone.
Thank you all.
Thank you. Thank you for having me.